In this example, we have a normal curve that has a mean of 55, and we're going to use that distribution to find all the answers for all the questions that are being asked. Now, we haven't been given enough information to do this on StatCrunch, not that we know how to find that yet anyway, because that's the next section. But we're still going to be able to do this because we're going to use symmetry and the properties of the normal curve. Okay, so let's see here. We were given a particular section. We know that this little skinny section right here, from 55 to 62, has an area that is 0.2123. Now, this is not a standard deviation. That's not how this is working. It's more just we know what this value is and it was given to us. Okay, so we're going to use that value to find everything else. So I'm going to make this area to the right of it, right here. I can find this area, believe it or not. Now, how can I find that area? Well, the thing is that I know that the normal curve adds up to 1. Right? I know the area under the entire curve is 1. So let's think of the normal curve properties that we need. So the area under the whole curve is 1. But then I know that the area to the right or left of the central line of the mean is a half, is 0.5. We learned that with our properties of the normal curve. So I can use that to find this area right here, because this is the central line. I know these two sections, this dark gray one they gave me, and this one must add up to 0.5. So if I take this piece and I take 0.5, which is what both of them must add up to, and I take away the 0.2123 that I was given, I'll know this green tail over here. Well, let me go grab Desmos and do that calculation. 0.5 minus 0.2123 is 0.2877. All right, so I know this section over here is 0.2877. I know this gray section that was given was 2123. All right, what about the other side? How am I going to find that? Well, I know this white section right now is 0.5, but that's not really what I'm looking for. So what I want to do is I want to make a companion to this side. So this height is I'm going to match over here, and this width over here I'm going to match over here, and then I'm going to line them up. Grab my ruler. Like that. It's not perfect, but it'll work. Okay, now I know what that section should be, because that section, by symmetry, is the same width as the section I already had, the charcoal section that was given. So that pink section that I just found should also be 0.2123 by symmetry. Now the question comes up, what is this number? Right? Where is this coming from? So this is the mean. So how far apart are these two? Let me do it over here. 62 take away 55 is 7. So these two are 7 apart. So I need another number that is 7 over from 55. So 55 take away 7 would be 48. So this number over here is 48. So I have 48, I have 55, and I have 62. And those three numbers, if you'll notice, are the numbers that are popping up all over the place down below. All right, what about the last tail? The tail over on the far left. Okay, well, I know how much that tail should be also, because that tail should match the blue tail in terms of area. Sorry, I mean the green tail. So the blue tail, because I'm about to shade this one blue, the blue tail and the green tail match in area by symmetry. So this blue zone right here and the green zone over here are the same. So this blue zone also has to be 0.2877. So we find these four values, and it's a little bit of a puzzle, right? You know that the four areas must add up to 1. You know each side is 0.5. But honestly, once you find two of them, you know they're companions over here because of symmetry. So we're using symmetry and the fact that the curves add up to 1 and add up to 0.5 on each side to find all of these values, right? Each half adds up to 0.5. Okay, so now that we know that, now we can answer all the questions. All right, so let's look at them. So this one wants the probability that x is greater than 55. Well, greater than 55 would be this gray section and this green section, right? Greater than is to the right. So that would be 0.2123 plus the green section, which would be 0.2877, which of course we already know what those add up to. That's how we found it in the first place. It's 0.5 or 50%. All right. What about 55 to 62? What about just this section from 55 to 62? X is between those two. Well, that's just the charcoal section that was given. So that's 0.2123. So far, this is not bad at all, right? Okay, now what about greater than 62? Well, greater than 62 we already found. That's the 0.2877. It's only the green section. All right, what about 48 to 55? 48 and 55 is right here. It's this pink section, which we already know what that is because by symmetry it's the same as the charcoal section. So that's also 0.2123 by symmetry. I mean, all of this is really by symmetry, but that one in particular. All right, what about less than 48? Less than 48, 48's right here. Being less than is to the left. So that would be the left tail, so 0.2877. Right? It's the left tail. And then this piece was the right tail. All right, what about less than 48? All right, less than 48 would be the blue section, or greater than 62, that would be the green section. So less than 48 is this piece, right? 0.2877 plus greater than 62 would also be 0.2877. So we need to add those two up, right? We learned in chapter 5 that OR means add. Technically, we actually had it in chapter 2. Right? We had it a long time ago. So we need 0.2877 plus 0.2877. Or if you will, it's 2 times 0.2877. Right? That's what multiplication is. So 0.5754. All right. Oh, and you might want to make a note just for your own sake. That's a greater than. Right? It points to the right. So greater than. And this one's also a greater than, just in case you're wondering. Remember, you don't have to memorize those. They're in your exam note sheets packet under chapter 6. It tells you under the binomial distribution which symbol matches with what word, but just in case you want to remember there. All right, so back I go to this one. The probability that x is between 48 and 62. Okay, so 48 to 62 is these two sections right here. So 48 starts here and it goes all the way to 62. So that would be the pink section, which was 0.2123, plus the gray section, which was another 0.2123. Heading out to grab that in Desmos real quick. 0.2123 plus 0.2123 makes it 0.4246. All right, what about the probability that x is less than 62? Well, there's a couple ways you can do this. Less than 62, 62 is right here. So everything less than would be these three sections, the blue and the pink and the gray. So you could do that. You could say, okay, that's 0.2877 plus 0.2123 plus the gray section, which was another 0.2123. And we could add all of those up and get an answer. Now there is another way. There's a cleverer way. So I'm just going to say or. And that it's fine if you want to add them up, no problem. But what was the one section that wasn't in there, right? It was these three were being added up. So the only section not in there is this green one. And remember, the whole curve makes 1. So if we say 1 for the whole curve and I take away the green one, I would have the same answer. So you could say it's 1 minus the 0.2877. All right, so let me prove it to you. If I grab Desmos and I say, hey, what's 0.2877 plus 0.2123 plus 0.2123? That's adding them up. What's 1 take away 0.2877? See, it gives you the same answer. So it's fine either way. They're both 0.7123. Now there's one other thing to notice here. Right? So whichever one you want to circle is fine. Did you notice how sometimes I said less than and sometimes I have a less than or equal to sign? Right? Why does it not matter? I ignored it entirely as I was doing the problem. And that's because it doesn't make any difference, because this is a continuous distribution. So that's just one last thing to note. Right? In a continuous distribution, remember that the probability that x equals any particular number is 0. Okay, so that means that it doesn't matter whether you include the number or not. So a less than and a less than or equal to are the same. Also, a greater than and a greater than or equal to are the same. It doesn't matter because the equal to part doesn't add anything. It adds no probability. The line itself has no area, so the line itself does not add any probability. That's why sometimes I can say less than and sometimes I can say less than or equal to, and it doesn't make any difference.